This will serve as a quick overview of the main research methods used in psychology. Research methods can be one of the more difficult topics for the class, so pay close attention and do your best to understand the 4 main research techniques that psychologists use. The first type of research that psychologists use is what's called a case study. Now, case studies in their name tell you exactly what they are. A case study is when someone studies one case or one person. And in psychology, we like to help individuals, but our goal is typically to learn about everyone in the world. So we try and study one person in a case study, but then apply whatever you learn to everyone in the world. So for example, let's say we were studying someone who had schizophrenia, and this person was having hallucinations and delusions and really struggling with their disorder. But every time they drank iced tea, they noticed that you noticed that they got better. The thought with the case study would be, well, let's let all schizophrenics maybe drink iced tea and maybe they will all get better. Now, of course, this is an absurd example, but I just give it so that you can illustrate what the main point of a case study is. Generally speaking, case studies aren't always that useful because there could be that one odd schizophrenic who gets better by drinking iced tea, and the rest of them don't get better. But there are sometimes rare disorders that you can only study via case studies. If you can only find 2 or 3 people with some problem, well, it's better to study them with a case study than not study them at all. The second type of research is called observational research. And again, in the name, it tells you exactly what it is. With observational research, we research by observing. Some of this can be very simple observations, and some of these can be far more complex. Some of the main studies that have been done in the past have looked at father-son interaction, mother-daughter interaction. If you ask a parent which of your children like science more, the boy or the girl, most parents will say, well, they're boys, their sons have more interest in science. But is that because they were, let's say, born that way? Or is that because maybe the parents pay more attention to the boys when it comes to science? These are questions that psychologists try and answer through observational research. There was a study that went to a children's science museum, and what the researchers did is they just looked around and watched how much time the parents spent with each of their kids at each exhibit. And what they found is each parent, mother and father, were more likely to spend longer at each exhibit with the sons, explaining it more, than with their daughters. If you had just asked the mothers or fathers, do you spend more time with your sons versus your daughters? Most wouldn't admit, we spend more time with our sons. But for the most part, that is what this study found. There are a lot of students that are interested in becoming nurses that come to Rio Hondo, some that want to be doctors as well. Doctor-nurse interactions are the center of a lot of very interesting observational research. For example, a lot of researchers have found that nurses don't always agree with doctors, and they may not speak up to contradict a doctor. The doctor is the one with, let's say, the higher degree and who might be more in charge. But a nurse may know the patient a little better. And so we want to find ways to, let's say, design a hospital environment so that a nurse might be more likely to speak up when he or she feels the need. The last bit of observational research I want to kind of highlight as an example comes from the woman in the picture here. This is Jane Goodall, and she did observational research with chimpanzees. She started off by just watching them from afar, and as you can see in this picture, she eventually got to the point where she was interacting with them. So maybe a modified type of observational research, but she believed she could learn more by interacting than by simply observing from far. The third type of research, and the one that we're going to spend the most time on for this lecture, is called a survey. You've probably taken a survey in some form or another at some point in your life, whether it was even after you ate a meal. How was the food? How was the service? Some surveys are very simple in what they're looking for, but most research-based surveys have more than one question, and typically what researchers are looking for is how one question relates to another. So for example, the survey that you see in front of you has two main things that people would have to respond to. These researchers weren't all that interested in how people responded to the first question, or first statement, which is that criminals convicted of murder should be hanged. How many people agreed and disagreed, strongly disagreed, etc. And they weren't all that interested in how people responded to the second statement, trial by jury should be abolished. How many people agreed and disagreed, and so on. However, what they were more interested in from this survey was, do these two statements have a relationship with each other? So for example, if you said, I strongly agree that criminals that are convicted of murder should be hanged, how do you then feel about the trial by jury system? Should we abolish it, that is, get rid of it? Should we maybe keep it? Maybe you feel if we're going to hang someone, we better have a very good jury system. So they wanted to look and see if these two things had any kind of relationship with each other. To examine whether two items have a relationship with each other, we use a statistic known as a correlation. When you hear the word correlation, I want you to think relationship. Correlation, relationship, right? The word relation is the same in both of them. And correlations examine the relationship between two things. At its most basic, a correlation will ask the question, as one thing increases, what does the other do? Does the other increase as well, or does the other decrease? For example, we could look at, as height increases, what does weight do? As height increases, usually weight increases as well, right? A taller person usually weighs more than a shorter person. Now, this isn't always the case, but most of the time it is. Now, because correlations are math, they are statistics, they can be graphed. On this slide, you have three graphs, each of a positive correlation. Now, math is not a requirement for this class, but I would assume most of you have at least had some basic algebra and could tell me that since the line is going upwards, it has a positive slope. So here we have three lines in these graphs, all with positive slopes. And that is the idea behind a positive correlation. Now, if you look at each of these, imagine height and weight on the two axes. If height is on the bottom and weight is on the left, what you have is, as height goes up, weight goes up. Right? As you move from left to right, your line goes up. This happens both in the top graphs and in the bottom graph. Notice that The difference between the three graphs is how spread out are those dots. The first one on the top left has the dots in a perfect line, and this is called a perfect correlation. Imagine that height and weight were like this. If I knew your height, I would know exactly what your weight was, because for every height there was an exact weight that was linked to it. But height and weight aren't really like this. It's more like the second graph, the one that's on the top right. Think about height and weight this way. If I know your height, I probably have an idea about your weight. Let's say you are 6 feet tall. I probably have a guess that you're probably somewhere between 160 pounds and 180 pounds or 190 pounds. You're probably not 6 feet tall and 90 pounds. That would be a little awkward. You're probably not 5 feet tall and 400 pounds. That could happen, but again, that's not exactly what we would expect. Someone who's now, let's say, 5 feet tall is probably in a range of somewhere between 110 pounds and 150 pounds. So again, we have ranges that we might be able to look at. The very bottom graph has an even bigger range, an even bigger spread. So notice that one is called a low positive correlation, and the one on the top right is called a high positive correlation. The broader your dots, the lower the correlation. And we'll talk more about that in a couple slides. Here we have two examples of a negative correlation. Notice that if I move across the bottom from left to right, my line goes down. So this would be as one thing goes up, the other comes down. Think about the price of gas and how much people drive. The lower the price of gas, usually the more they drive, right? So the higher gas goes, the less they drive. These are negative correlations. Again, you see the difference between the left and the right here as being a matter of spread. The dots on the left graph are all perfectly in line with each other. So this would mean that for every dollar that gas came down in price, I would know exactly how much people would drive, perfectly. But remember, the world doesn't really work that way. And instead, it's more of a range. For every dollar that gas comes down, people will decrease by a range of amounts. Sometimes there is absolutely no relationship between your two variables or two things that you're looking at. And in those cases, you have what is called no correlation. Notice the dots here are all spread out. They're not generally going up. They're not generally going down. This would be kind of like if you looked at your height and how far you live from school. Taller people don't necessarily live further from school than shorter people do. It's all over the place. There would be no real way to predict how far someone lives from school based on their height. Now, because correlations are statistics and statistics are math, we have variables for correlations. And the main variable that is used that you need to know in here is called R, which is a correlation coefficient. Now, R is always in between +1 and -1. An R of 0 means no correlation. And if you think about it, we talked about positive correlations and negative correlations and no correlations. So if 0 means no correlation, and you can have positive and negative numbers, you might be able to predict that the positive numbers go with the positive correlations and the negative numbers go with negative correlations. The closer you are to 1 with your R, the stronger the positive correlation you have. So if you think back to the slide that had the graphs, some of those graphs had the dots really far spread, and some of them had them really tight, like one straight line. The one straight line graph would be very close to 1. The one that was very spread out all over the place, that would be closer to 0. The same is true for the negative. So the slide that had the line going downward, the line that was a straight line with the dots would be very close to -1. It would be a very strong negative correlation. As those dots kind of start spreading out more and more and more, you get closer and closer to 0 with your number. Now, what's very important for you in this class is to be able to not just look at what a correlation is and so on, but what does it actually mean? So what does a correlation mean? For example, let's say that low self-esteem correlates with depression. What does this mean? Most people, when they hear this, they immediately start using the word cause. Does low self-esteem cause depression? It could, but what we learn from a correlation is that low self-esteem is linked, is related to depression. Because the problem is, sure, low self-esteem could cause depression. If you don't feel good about yourself and you have low self-esteem, that could make you more likely to be depressed. But the reverse could be true as well. Could depression cause low self-esteem? If I'm depressed and sad, I maybe start to look at myself in a different way, and I see myself as not being very smart and intelligent and bright, and so maybe depression causes low self-esteem. Or there could be something completely outside of self-esteem and depression that causes both. For example, what if you just got dumped? If you just got dumped, perhaps you now have low self-esteem, and perhaps you're depressed. But the low self-esteem isn't causing the depression. The depression isn't causing the low self-esteem. The fact that you just got dumped causes both. So we have to be very careful using the word cause whenever we look at a correlation. In fact, this is kind of the mantra of our class. Correlation does not equal causation. And what I mean by that is whenever you're looking at a correlation, you cannot conclude anything solid about whether one thing causes another. In fact, we can never, ever, ever find the cause of something using correlations. All correlations give us is the relationship between two items. So it can tell us when height goes up, weight goes up, or when height goes down, weight goes down. But it does not tell us that an increase in height causes that increase in weight, or vice versa. As an example about correlation not equaling causation, and there are many out there, there was a study that looked at contraception use in the Philippines. And specifically, these researchers wanted to know what is the most effective way to get people in the Philippines to use contraceptives. There was an overpopulation problem, so they wanted to figure out how to slow the population growth. And this study did a survey and asked people how often they used contraception, and then they asked them all sorts of other questions about their life. And the number one thing that they found that correlated with how often they used a contraception was the number of household appliances that they had. Notice the line is going upward, and the correlation number at the very top of the graph says 0.73, so it's positive. The more household appliances you have, the more often you use contraceptive. Now again, this was proposed as a means for population control. But think about it. If this is really cause and effect, let's just buy everyone in the Philippines a toaster. We just increased their household appliances, and so they should all of a sudden now start using more contraception. And that doesn't really make a lot of sense. So something else had to be causing this. And in fact, what the researchers found is that socioeconomic status was the real determining factor here. So the wealthier a family was, the more likely they were to be educated. And the more educated they were, the more likely they used contraception. The wealthier they were, the more appliances they had. So that was how these two things really were linked. Now, the last research technique that psychologists use that we're going to talk about is called an experiment. Now, experiments do what surveys and correlations cannot do. Specifically, they find cause and effect relationships. There are two main terms that go with experiments that you will need to be able to identify, and those are independent variables and dependent variables. Independent variables are manipulated and dependent variables are measured. To go through a quick example, let's imagine that I am growing tomato plants and I want to see whether fertilizer helps. So my question is what effect does fertilizer have on tomatoes? To set up a really simple experiment, I will have two groups of tomato plants. The first group gets fertilizer and the second group gets no fertilizer. Then we look at which group gives more tomatoes. Your independent variable is what you manipulate. Now, some students will say, I'm manipulating how many tomatoes I get. But I'm in fact not doing that. I'm looking at how many tomatoes I get, but the only thing that I have direct control over, that I directly manipulate with my own hands, is whether it's getting fertilizer or not. So your independent variable is actually the amount of fertilizer the tomato gets. Your dependent variable is what you're looking at, what you measure. How do we know which group wins? How do we know which group we're happier with? And that, in this case, is how many tomatoes we end up with. The last thing to discuss regarding experiments and research is within psychology, especially drug studies for psychology, we need to make sure that we talk a little bit about what's called a placebo effect. Now, if I tell you, take these pills, they're going to make you feel better. The amazing thing about the human brain and the human body is in most cases, people will start feeling better even if the pills did nothing. This is called the placebo effect. So knowing that you're being helped actually makes you better. A placebo is any fake drug. So what we do in studies is if I want to figure out whether aspirin helps people with headaches, I will give half of the group aspirin and the other half I will give a placebo, a fake drug. In some cases, a placebo is a sugar pill. In other cases, it might not be a sugar pill. It might be something else. So placebos are any fake drug. If the drug that I'm testing out is liquid, I wouldn't want to give my group 1 liquid, the drug, and then group 2 a sugar pill. You would want your placebo to look a lot like your real drug. So maybe there we would give them saline or some sort of, water type solution. Now the other thing that goes along with placebos is when you conduct an experiment with placebos, you want to make sure that you run what's called a double-blind experiment or a double-blind procedure. What we mean by that is when you give someone a drug or you give the other half of the room the placebo, you don't tell them what they get. They think they maybe got the drug or they think they got the placebo, but you don't want to tell them whether they got it or not until the experiment is over. So your subjects are essentially blind. They don't know what they have received. The other person who doesn't know what they received is actually the treatment doctor. The treatment doctors shouldn't know what the subjects received because they may act differently around them if they know that they got a placebo or if they know that they got the real drug. Now, someone in the experiment, of course, has to know what they got. So usually that person doesn't interact with the subjects and maybe works more in the lab and so has all of that on records, on paper or something. So officially a double-blind procedure is when neither the patient nor the doctor knows whether they received the drug or the placebo. And it's blind, it's double-blind because it's the patient and the doctor. So there's two levels of blindness.